remember the last point. All the equilibrium price system must have all positive components. Now, let us prove the main result. If every good is a gross substitute for every other good, then the price equilibrium is unique. In this case, we can restrict for sake of calculus, and for sake of easier calculus, to the set delta. Well, let us suppose that there are two different equilibrium price systems, P prime and P double prime. Remember that both of these equilibrium price systems has all positive components. For example, in the case of two goods, you have P prime here and P double prime. These are our two price systems. Since all the components of these two price systems are positive numbers, you can compute, for every good, say K, the ratio between the kth component of P double prime and the kth component of P prime. All these numbers are positive numbers as well. Well, consider the maximum of these different ratios and denote it by mu. Mu is the greatest ratio between the components of P double prime and the corresponding components of P prime. In our case, clearly, mu is equal to the ratio P double prime 2 on P prime 2, because this price is increased when you pass from P prime to P double prime. While the price system, the first component of the price system decreases when you pass from P prime to P double prime. Well, consider this point, with this maximum ratio. And now consider another price system, mu times P prime. Where is? You must multiply every component of P prime by this mu. Clearly, you obtain this point, approximately, mu times P prime. Is it clear? This is only a construction in order to prove more easily our theory. However, when you pass from P prime to mu times P prime, by absence of monetary illusion, you have clearly this equality. The set of excess demand vector in mu times P prime must be equal to the set of the excess demand vector with P prime. Is it clear? In our case, to simplify notation, the good for which there is this maximum increase in the price is good 2. So you have that while the second component of this vector mu times p prime is equal to the second vector of p double prime 2. Because the price of good 2 is the price for which this ratio is maximum, while the other is inferior. Here is p double prime 1 is lesser than mu times p prime 1. So we can apply gross substitutability. When you pass from this price system to this price, or vice versa, from this price system to this price system, one component remains unchanged. Sorry, here is 2. One component remains unchanged, while some other components, in this case only one component, of course, increases. When you pass from p double prime to mu times p prime. So you can apply gross substitutability for every z in z of p double prime, for every z cap in z of mu times p prime, you have that z1 must be lesser than z cap 1. Why? Z2 must be lesser than z cap 2. Why? Because when you pass from p double prime to this price system, the price of good 2 remains unchanged, while the price of some other good, in this case good 1, increase. And so clearly also the excess of demand of good 2 must increase, because good 2 is a gross substitute of good 1. By applying our property of gross substitutability, you obtain exactly this result. But remember that both p prime and p double prime are equilibrium price systems. So 0 must belong both to p prime, to z of p prime, and to z of p double prime. But since z of p prime is equal to this, z of mu times p prime intersection with z of p double prime. This equality is justified by this absence of monetary illusion. But clearly this is impossible, because this would mean that 0 excess demand vector in equilibrium, the first equilibrium, must be lesser than itself another time, and this is impossible. Contradiction, and therefore the theorem is proved. If gross substitutability among goods holds, then there is at most one equilibrium price system. Well, it has repeat all the proof. Consider, suppose ab absurdo, that there are two different equilibrium price systems. Remember by our previous lemma that both this vector has all positive components. So we are able to compute this ratio, these ratios, P double prime K on P prime K for every group, because all these prices are positive. Consider the maximum value of this different ratio and denote it by mu, which is a positive number. For example, in this case, you have P prime, P double prime, and the maximum increase in a price is that relative to good true. So mu is in reality P prime 2, P double prime 2 on P prime 2. From this equality, this other equality immediately follows. For the other good, you are, or for some other good, you are surely in an inequality. Otherwise, our two-price system would coincide. Now, let us apply gross substitutability. Take any x-demand vector z in z of P double prime, any x-demand vector z cap in z of mu times P prime. When you pass from P double prime to mu times P prime, the price of good 2 remains unchanged, while some other prices increases. By applying gross substitutability, the excess of demand in the situation mu times P prime must be greater than the excess demand of the same good 2 in the first situation. This is simply an application of gross substitutability. But remember at this point that both price systems, P prime and P double prime, were equilibrium price systems. So the vector z must belong both to z of P prime and to z of P double prime. Because the definition of equilibrium can be rephrased by saying that this result holds. By absence of monetary illusion, z of P prime and z of mu times P prime are the same set. So 0 must belong both to this and to this set. But this is clearly contradictory with our previous result, because in particular this would mean that 0 is lesser than itself. Since in equilibrium the excess demand of good 2 is 0, by this result we obtain 0 lesser than 0. Impossible. And therefore the theorem is proved. It's not so difficult a theorem, but all these indexes, primes, double prime, etc., can confound ideas. Or it's simply an application of gross substitutability. Well, let us have another short break.